Okay, so I'm Saida and I'm presenting my module 3. Thank you for your flexibility with me. So far this semester, I've been looking at various elements of gender, starting with the influence of media on parental self-efficacy, and then developing a scale on perceptions of sexism in the world today between men and women. Over the course of my research, I realized that I wanted to focus more on the experiences of men themselves that relate to their experience of masculinity. I wanted to explore whether different aspects of masculinity contribute to anxiety. So this has implications for both fatherhood and for gender relations, which is what I looked at before, but it also has implications for men's mental health in general, and this is an understudied field that I'm interested in going into. I'll be looking at psychological connectedness to other men and feelings of competence and masculinity. So alpha males will conform to traditional masculinity, and they're especially competitive and dominant. Beta males have more flexible and somewhat liberal masculinity norms and don't behave as dominantly for various reasons. And lone wolves kind of do their own thing. So I will be using the general linear model to predict the continuous variable of anxiety symptoms. Today, I will present results from a standard least squares multiple regression and an ANOVA. We use these two operations to predict continuous variables, such as anxiety, which is dimensional in nature. It's important to use continuous outcome variables, as King cautions against using dichotomous dependent variables. So we have y here, the outcome or dependent variable. Here is the intercept, so it represents our best guess when there's no predictor present. X here represents the matrix of predictors that may account for the variance in Y. Generally, we choose to test predictors based on theoretical models. B is the weight assigned to predictors, and E is the residual in MRC or error in ANOVA, which we'll talk more about later. And the GLM generalized to multiple specific models. They must all be additive and rectilinear. So as Patrick likes to say to make these two variants more understandable to us, ANOVA is like the woman you bring home to mom. She's a lady, prim and proper. And MRC is the 3 a.m. one night stand who plays fast and loose, is kind of more relaxed. She plays fast and loose with the rules, and she's also a bit more permissive. But since they're based on the same model, we can actually bridge back and forth between them. ANOVA and MRC have similar underlying assumptions and requirements. They both use hypothesis tests with omnibus as well as main effects. And the assumption is that these effects are additive. The purpose of both and also the GLM in general is to understand variance, so they're critical tools in social science research. But they're also different. Like I mentioned earlier, ANOVA is a bit more constraining. The level of measurement used for predictors in ANOVA is nominal or categorical, so predictors are called factors. In MRC, predictors are covariates and measured in continuous variables. And one final thing that's really important is in terms of determining the fit of the model, MRC actually treats differences between observed and predicted values as errors in the model. I mentioned before that we test predictors based on theoretical models from literature, but we don't often get the complete picture because the human condition is complicated. We often leave things out, and that's the excitement of science, is that we always get to explore more. So MRC acknowledges this and calls errors residuals, meaning that there's always a potential of residual covariance with the dependent variable, and that means that there may very well be additional predictors we haven't yet measured. Conversely, ANOVA treats differences between predicted and observed outcomes as errors, meaning that when observations don't match up with the prediction, it's because the observation is wrong. Sounds kind of cocky, if you ask me. So we're looking at relationship between masculinity and anxiety. Speaking of cocky, so I want to see how different aspects of the experience of masculinity predict anxiety symptoms. So we already know that endorsing traditional masculine norms is more associated with depressive symptoms, so I want to see if that relates to anxiety. I want to look at masculinity contingency, which is the extent to which a man's self-esteem is tied to how well he performs masculinity, and also at masculine gender role stress, which is the extent to which a man feels stress from situations that challenge the adequacy of his performance of his gender role as a man. So the B's here would be our slope, as we can see. And the slopes are our rise over run. So that's basically how much our outcome rises for each 1 unit of increase in our predictor. For example, a 1 unit increase in X1 or conformity to masculine norms actually results in a 0.3 increase in anxiety symptoms. So the T values are the ratio of slope over standard error or signal over noise. In this case, we fail to reject the null for all main effects, which means that none of these experiences of masculinity predicts a man's level of anxiety. But we do get to reject the null hypothesis of no effect for our omnibus test, which tests the fit of our whole model. As Cortina importantly notes, we can only reject or fail to reject. We cannot accept our null of no effects simply because we fail to reject it. All right, so I'm thinking that maybe there's some multicollinearity happening that's confounding our ability to detect effects. So let's look at diagnostics. So there's 9 assumptions of the MRC. With diagnostic tools, we can examine if our model violates any of the more critical assumptions. So looking at the significant omnibus contrasted against non-significant individual predictors or main effects, I mentioned there's possible multicollinearity. To assess this, we're going to use the variance inflation factor, or VIF. This lets us know that variance has been inflated by covariant predictors. Even though such a basic test without closer inspection may seem lazy, the fact that the VIF outcome is close to 1, showing little inflation here, reflects that multicollinearity is not an issue with our data. The residuals versus fitted tests, this plot detects if the rectilinear assumption has been violated, and it allows us to see unequal error variances and outliers. The scales location plot examines if residuals are spread equally across the ranges of predictors. This is how you can check homoscedasticity, or the assumption of equal variance across the range of predictor values. So this horizontal line with randomly spread points shows us that our assumption is sound. This normal QQ graphic plots theoretical quantiles against standardized residuals. So it tests the assumption that residuals are normally distributed across the quantiles. And then this last plot helps us to detect particularly influential single observations to see if one particular data point is skewing our results. So we look at both leverage and discrepancy. All right, so now we're going to look at our ANOVA, which is going to be looking at predictors which have class level measurements. So those are categorical variables. So what we're going to be looking at is the effect of experiencing a stressful life event, which is going to be measured as yes or no, a dichotomous variable. And then we're going to look again at conformity to masculine norms, but we have transformed it into a dichotomous variable by splitting at the median value. Unfortunately, this really blurs a lot of the nuance in this predictor, but we also want to be able to use stressful life event as a predictor to see maybe if that relates to anxiety symptoms, or if together they kind of interact. So if you have low conformity and you experience a stressor, you have less anxiety perhaps than if you had more conformity. So what we see here is our F value. So this is what the ANOVA kind of spits out at us. None of them here are significant, but just to talk about the F value, it is basically the variance of between groups. So between, here it would be between the groups who experienced stress and those who did not in the past 6 months. And then in the second variable, it would be between those who are in high conformity versus those who are low in conformity. And we'll look at the variance between the groups and then the ratio of that over the variance within the groups. And that's actually another way of saying signal over noise. So the signal is, what you think the effect is between the two levels of the variable. And then the noise is all of the blurredness within any one group. And if that's higher, then you can't really say that there's as much of a distinction between the two groups because they're both kind of more or less all over the place. So we also want to look at diagnostics because it's always a good idea. So, so in terms of testing the assumption of normality, we have this QQ plot, which gives us a visual. And then actually I have this on the next slide, but the Shapiro-Wilk, as you can see here, is not significant. So that means that we're good on our assumption. And then we also want to test the assumption of the homogeneity of variances. And that's the assumption that the variance of the population values of each group should be approximately equal. So that's these are four of the important assumptions. First being the population values of each group should be normally distributed. Outliers should be rare, and the observations should be independent within and across groups as well. So we're seeing here that the Bartlett tests are non-significant, and so are the Shapiro-Wilks. So I think our assumptions are good. And that was basically an overview of the general linear model and some of the GLM diagnostics. So although we didn't find any really significant results for our predictors, it was fun to talk about them. I actually am doing my lit review on masculinity, so this has been fun. And here are my hand calculations for your review. This is my MRC, and you can see that there. And then here is my overall picture of my ANOVA for lab 12. And here's some of the background to that, so I did the work. And that's it. Thank you so much. This was a really enlightening semester for me, and I really feel like I learned a lot from you and just learned more about how to be a more critical thinker when it comes to science and reading papers and digesting it. So thank you. Take care.